Okay, property of exponents. Let me say how much you put into your memory. How about let's try 1 or 2. Okay, can you do this? And can you do, yeah, how about this one? Okay, looks good. Oh, how about another one?
It would be
Help me. Okay, good. Then let's keep going. Yeah, here talk about the zero exponent. A zero's power equal to 1. But especially if zero's power is undefined. Yeah, so anyway, you just remember this rule. Then negative exponent. If A, yeah, here talk about if for negative 2's power actually is equal to 1/4 square, right? And generally we have this, and we have this. A not equal to 0. Then let's say if you can remember this rule. Yeah, you see here 6 times 7 zeros power. We know 7 zeros power is 1, so times 6. Oh, hold. No. Here not 6 times 7. It's 6.7, right? Yeah. Say 6 times 7. 6.7. So can you find the difference? if it's multiplied, the dot in the middle. If it's the decimal point, it's like in the bottom. That's one thing. Another is 6 times this dot like take one place, like 6 or 7. If 6.7 suppose this, then take a place. Just like 6, 7, but you have a point here. Okay. Here talk about the exact value or number. Then here use the variable. So we have 4x 0's power y. Y negative 3. When go from denominator to numerator, it's go to y3, right? Correct? Then 0's power just means equal to 1. So we will not write it anymore. Here just has 4. So y3 or y cube. Yeah, by this, could you do problem 1 and problem 3? Yeah, please do this two first. Keep going with problem 3. Okay, let's stop here. Let me tell you, this is not correct. Not correct. Okay, let's go back to check the core concept again. Can you find here? Generally, a 0's power equal to 1. A negative n, next example here, 4 negative 2's power equal to what? 1 over 4 2's power or square, right? So it's nothing to do with negative. For example, 4 negative 2, oh, go to negative 8. No, nothing to do with negative. Yeah, you can think in this way. Yeah, let me just close this. And Yeah, you can think in this way. For example, if 4 5's power, for example, it means 4 times 4 times 4 times 4 times 4. How many times? 5 times, right? Yeah, this is the basic one you should understand. But what means for -5? This negative never means the value of this expression is negative. No, nothing to do. It means you can think starting from 1. Just now you can also think from 1 times 4 times 4. If 5 times means 5 times of 4. Okay, here negative just means starting from 1, you divide 4, divide 4, divide 4. How many times? 5 times. Yeah, that being said, this negative tell you it's not multiply, it's divide. Okay. So that's why we have this. Now you go back to say it. Yeah, you can find 4 negative 2's power is equal to this. What's this mean? It's like 1 divided 4 divided by 4. How many times? 2 times, right? That's the reason we get this. So if it's n's power, negative n's power, it means starting from 1, divide a, divide a, divide a, divide how many times? N times. Then you can also understand, oh, if here is 0, means you starting from 1, you multiply a, multiply how many times? 0 times. So you still get 1, right?
Yeah.
Okay, then you can see the example again. Y this equal to 1. Y part B, y this equal to 1 over 16. Right? You say -4. This negative never mean the value of this expression is negative. It means we should divide this instead of multiply. That's the reason it's go to the denominator, right? Means divide. Okay, anyway, now let's say, could you provide answers again?
Mm,
Do you want to say the rule again?
yeah.
Okay. You say the rule tell us if a's 0's power just equal to 1, the only condition is a not 0. Means a can be positive, negative, fraction, decimal, whole number, never mind. If a not equal to 0, then a's 0's power just equal to 1. Right? Then the second question, if a negative n's power, then it's equal to 1 over a n's power. Okay, then let's try. Oh yeah, okay, you get an answer for first one. Yeah, that being said, there are two cases. One is negative 9. What's this equal to?
And it would be
Yeah, if you don't just say you don't know, it's okay.
yeah, I'm a bit confused.
Oh, okay, yeah. You can think this as negative. Yeah, that means that the base is, this time the base is 9 instead of negative 9. When with this means all these are the base, right? Okay, so, oh, come on. So what this should be? Nine zeros power, 9 zeros power. What should it be? What? 1. Then negative. So together negative 1. So can you find the difference? If with the parentheses means all these are the base. All these are numbers. This number's zeros power, of course, equal to 1, right? But if without this, the base is just 9, and negative is negative. Okay. Yeah, take your time to think about it. Then how about problem 3? Yeah, for problem 3, you made a similar case like here, right? Okay, could you do it? Please redo it.
Would be 1 and
Yeah, let me know when you're done.
I think I'm done.
You done? Yeah, this time is correct. So this means negative, still negative. 5 zeros power means 1, right? And then 2 negative 2's power go from denominator to numerator. The negative is gone, so you get 2 square. Yeah, then it means negative 4. Okay, good job. Yeah, keep this idea. Oh, by the way, do you want a screenshot? Or you already done?
I already did.
Okay. Then keep going. This time it's not a specific number. It's a variable, but the rule is the same, right? So could you do problem 4? Yeah, the requirements is using only positive exponents. That means that for negative exponents, you always need to change it to positive exponents, right? Yeah, like we mentioned for negative 5. Then to make this positive, you go to this, right? or for example, if 2, -2, that's what we mean. Then go from denominator to numerator is go to 2, right? Okay, please try. If you feel confusion, you can do piece by piece. For example, what should be this? What should be this? What should be this? Yeah, do it first.
Should be
Yeah, okay. You finish one. Keep going. 3 -2's power. No. Okay, I know what you mean. You don't really run, but don't do this. Just keep as this. Or even just keep as this, right? Why go to repeating decimal? No need. Yeah, then x power of -5. Yeah, you just think x as 3, for example. Then what you can get? Then you get this, right? Then if this time is not 3, it's maybe 3, maybe 4, maybe 5, maybe half. Yeah, you just take it as x. Then what you should do.
Just X to be.
Done?
I think.
Of course not done. 5. Here is 5. Okay, yeah, together what you can get? Yeah, don't forget this is 5. Okay. I don't write it very well. But anyway, here is 5. Simplify it. It's correct, but simplify it. Okay, keep going, simplify it. Okay, it's just 1 over, you don't need to have 2, 1, right? And just have one fraction bar, 9x fifth power, right? Yeah, so suppose this is not necessary. Even this is also not so necessary. If you can quickly think, you can simplify out. 2, 1, 1 times 1 still get 1. Fraction means just one fraction bar. Okay, anyway. Please screenshot.
Okay.
Using the property of exponent. Yeah. So normally they give you an example first, then follow this rule. We get something general, right? You say 4 6 power multiply 4 3 power. Then together it's 4 6 plus 3. That means it's 4 9 power. Then generally we have this. Then quotient rule. Quotient rule 4 6 power over 4 3 power equal to 4 6 multiply 3. That means 4 3 power third power, or just call 4 cube, right? So generally we have this. So from this we can get two things. For example, if here is a negative 2, here is a negative 3. Then finally, this, suppose we have a negative 2 minus negative 3. Then just get a, right? Correct? You say
Yes.
m n m minus n. Yeah, another is if a, for example, a cube. This is also a cube. Then it's a 3 minus 3 equal to 1. Right? Yeah, anyway, from this general you can get nonsense. This help you to understand why we say a zero's power equal to 1, right? Correct? Yeah, if you want, you can screenshot.
Okay.
Then power of a power property means the full 6th power as the base, then cube it. Then we have this time is 6 multiply 3. So you get a full 18th power. So generally, if a m's power, then n's power to it, we get the exponent is m, product of m and n. Yeah, so this is easy to understand, right? You say you can just take it as 4, 6, multiply 4, 6, multiply 4, 6. Then of course you have 3 of 6, so that's the reason we get 3 times 6, right? Yeah, make sure don't confusion with these two cases, right? Mm. Then please see example here. Yeah, so let me know if you are okay with this exams, or if you have a question, just tell me. Yeah,
Okay.
you go through them carefully. Yeah, go through them carefully, and if you have a question, feel free to let me know. Are you okay?
Yeah, I think I'm okay.
You good? Okay, now it's your show time. Let me pick 3. Yeah, how about this? And then this. Yeah, I need one with variable. Let me see. Yeah, how about just this? Okay, yeah, please go. Yeah, do it as fast as you can. Yeah, make sure you see here. And problem 5 here. Yeah, for this, you need to keep going. As this is not too big or not too small, so you should write it as a regular number. Like, for example, for -3, you mean it's 1/4 cube, then it's this, right? Write it as a regular number. This is for problem 5 or problem 9.
This one is for
Or you still not done. And this is 102, or it's 10 square. Which one? I cannot understand.
that's
Yeah,
102.
102?
Yeah.
How you can get 102? It's strange.
10 and the 2.
No. Think it again. It means 10, the power is -2. Then I don't suppose it can go to 102. Think it carefully. So this is not correct. Yeah, just say what I write. 4 power of -3 equal to 1/4 cube. 4 cube, of course, means 64. So it's 1/64, right? Yeah, even you can just find this. Okay, we don't have so much of time. So here, per the rule, it's go to 1/this, right?
Yeah.
And what this should be?
So that would be
10 square. What 10 square should be?
100.
Of course. So here go to 100/1. 1/100, right? Yeah, anyway, not 102. We don't have a chance to go to 102. Then for, yeah, now let's check problem 9 and so you get, yeah, now it's correct. Then how about the problem 10? Let me ask you, for problem 10, do we have negative exponent here?
No.
No, so why they go to denominator? Oh yeah, now it's correct, right? Not 1 over this, just this, right? Okay, please screenshot.
Okay.
So again, find the rule is so important, right? You don't need to create some rule. Find the rule first. That's why we call this is learn. It's not create. It's just learn. Okay, keep going. Here mention, for example, if 3 times 5 as base, then power of 5, we can get is 3 fifth power multiplied 2 fifth power. Then we get a general rule. If product of A, B as base, m's power, then it is equal to A m's power multiplied B m's power, right? Then similar thing if A over B. Yeah, here has example 3 over 2. Fifth power, then it's 3 fifth power 2. Anyway, then find this, you get this rule. Of course, B cannot be 0 in order to make the denominator not 0, right? Okay, this time you have a chance. Oh, okay. Yeah, just go through the example. Yeah, please go through the example to say if you have a question or not. Yeah, let me know if you have question. Just follow these 2 rules. Are you okay? Yeah. Yeah, now let's try. Yeah, I just let you do the last one, 14. Yeah, here has a negative exponent, right? And here 6c is a product. 6c over 7 together, this is we call it a quotient, right? So let me mention the several rule we'll use. One is if a negative n, this equal to 1 over a n, this is 1. Second is if oh no, normally we use if a, b means product of a and b, m's power, then equal to a m's power, b m's power. Another is if a over b n's power, then we equal to a n's power over b n's power, right? Yeah, I suppose this is the three rule or three laws you need to use. Okay, could you try how you use these rules to solve this problem? Your result should not have negative exponents. Okay, so let me show you. Use the first rule. Let me change color. Use this rule. Here has negative 2, so we need to go to 1 over, you say, nothing else change, right? Then follow this rule. We have keep this no change. So 6's power over 7's power, right? Correct? Okay, then keep going. We know 7 square just means 49. Then use this rule. We get 6 square c square. Then here is 36 c square 49. And you can think this is 1 divided this. Anyway, finally you'll get 49 go up. So this is the answer. Okay, please screenshot.
Okay.
Now solving real life problem. Represent the volume of the cylinder, where R is the radius and H is the height. So yeah, the volume formula pi r square h. So h is this. H, the radius is half h. So together we get, yeah. So which one is the answer? This one. then solving a real life. Yeah, could you read this sentence?
Sure.
Example 6.
A jellyfish emits about 1.25x times 10^8 particles of light or photons in 6.25 x 10 to negative 4 seconds. How many photons does a jellyfish emit each second? Write your answer in scientific notation and in standard form.
Okay, so two form. One is scientific notation of form, another is standard form, right? Okay, so as this is the example, we just say use the total photons, divide the time, right? Then we have this. Yeah, then 10 negative fourth power go from denominator to numerator is go to 10 fourth power. So together we get 10 12th power, right? And this one is 0.2. So finally we go to 2 times 10 11th power. Yeah, it's very easy to write as a scientific notation. But if you write as a standard form, you have to be very careful to write how many zeros, right? Yeah, in order to do it, let me have a number and I'll let you write its regular. Yeah, how about we just say problem 16. Let me read it. It takes the sum about 2.3. By the way, here is not x. What it is?
Times?
Yeah, it's not x anyway. Per the common sense. We don't have an x here. Okay, let me keep going. 2.3 multiply 10 8 power years to orbit the center of the Milky Way. It takes Plato about 2.5 times 10 square years to orbit the sun. How many times does Plato orbit the sun while the sun complete one orbit around the center of the Milky Way? Write your answer in scientific notation. So many years to orbit the center. How many times does that means that in one cycle, in one period, the sun orbit the Milky Way. This is how many multiply of this small number, right? Okay, could you write the expression?
It takes the sun about 2.3 multiplied by 10 to the 8th power year. It takes the sun about 2.3 by 10 to the 8th power year. About to orbit the center of the Milky Way. It takes to orbit the sun 2.5 multiplied by 10 squared by 10 squared while the sun to orbit the sun orbits around the center of the Milky Way. While the write your answer in scientific notation around the center of the Milky Way. Write your answer in scientific notation.
Okay. So we just need to do this, right? Let me quickly see what's this equal to 2. Yeah, times 4. So this is 0. Yeah, could you write this as a standard form? You know, this is scientific notation or form. Now you write this number just as a regular number. Teddy， 你稍微等一下啊，我们快要下课了。
没问题。
好，谢谢。Yeah, write as a regular number or standard form. How about I leave this as your homework? Yeah.
Okay.
Yeah, write as a regular number. Or we call standard form, right? Okay, now I will assign homework to you. Please screenshot this. Done?
Yes.
Now let's say yeah. This is HW section 6.1. Right, then Q5. No, how about 6 to 72? Yeah. One from each 6 problems. Okay. Yeah, please screenshot this, then you can close your
Yeah, okay.
Okay, thank you, Winnie.